In this chapter, we will look at what stress risers are and some examples of stress risers in bicycle wheels.
If you are a bike exerciser, spend time as a good analyzer. Stay out of the coffin, inspect your wheels often, and learn to spot a stress riser. Wheels tend to fail for predictable reasons, and they fail because of weaknesses that occur at certain points, and that is due to the occurrence of what are called stress risers. And in this chapter, I'll talk to you about the typical stress risers to look out for in bicycle wheels.
We could look at a stress riser as a stress concentration point where there might be an abrupt change in geometry or localized loading, and we're going to look at a whole bunch of examples. A very familiar one is rim wear on bicycles with rim brakes. Here's a tube and tire with the tube installed but not inflated. We inflate the tube. These are the braking surfaces, which we see in the picture here as well. The sideward pressure from the tube and tire creates a turning moment here at the rim. As long as the rim is in good shape, it can withstand that stress. But from braking over thousands of miles, the sidewall starts to wear thinner. To this, then to this. And at this point, the rim cracks, the hook bends out, the tire comes off, and the tube explodes. This Allen wrench allows us to see light between the rim and the flat side of the wrench, and we can judge the amount of wear pretty easily by just that little trick. And thereby, hopefully, you can avoid having something like this happen. The next topic is nipple alignment and articulation. Looking first at this wheel and this hole here, the hole is going to be drilled straight through the rim, aiming for the center of the hub. But for any wheel other than a radially laced wheel, the spoke goes off at an angle like this. That means that the nipple has to articulate to point the spoke in the right direction. And that creates this angle. Looking at the wheel on the right in a different plane, we once again see that our nipples are going to have to articulate, in this case, in this plane, to aim the spokes for the correct flange. Details can be very important in wheels, and this is a good example of where nipple articulation is extremely important. So we're going to spend some time talking about each of these situations in detail, starting with the one on the left. This is a rim, and we're focusing on just one hole and also two nipples. This is a typical 12 millimeter nipple, and this is a Sypeme polyaxial 12 millimeter nipple. This graphic is showing us how the Sypeme nipple fits in the hole. This graphic is showing us how the other nipple fits in the hole. Here are the horizontal and vertical axes. And this is a tangentially laced spoke. The hole that the nipple has to go through is drilled, however, straight through the rim, aiming for the center of the hub. So the nipple's orientation is going to look like this. Fortunately, the nipple has a limited ability to change its direction. As we see here, it has aligned itself in the direction that the spoke is traveling. The Sypeme polyaxial nipple, after having rotated slightly, is still making good contact all the way around the hole. The other nipple, however, is less bowl-shaped in its underside and is less able to make perfect contact in all 360 degrees. Sometimes that's not enough to achieve perfect alignment of the nipple. For example, here, let's say the spoke actually goes off in this direction. The nipple cannot rotate any farther because when it tries to, it hits this corner right here of the hole. And that can predispose the spoke to early fracture because of the fact that it has to make that sharp angular change in its direction. Now, what I've successfully done a number of times when I have observed this happening is I've taken a very, very fine round file like you see there, and I have filed off these two corners to allow the nipple to swivel a little bit more. This is what the graphic looks like after those corners have been filed down slightly. And by the way, I've done this with aluminum rims a number of times and also carbon fiber rims. You have to be careful not to take too much material out. All you need is just a little bit. And that allows the nipple to go from this position before the filing to this position after the filing, where it has straightened itself out and is now oriented the same direction as the spoke. Just to be clear, every time I see a nipple that does not have perfect alignment, doesn't mean I get out a file and start cutting away at the rim, but I'll do it if I cannot otherwise account for why a spoke keeps breaking in a particular wheel. And that would be particularly here where the spoke has to change its angle. Now we're going to look at how we can beneficially use certain kinds of washers. These are 4 different kinds of Sapim washers, and we're going to look at each one of these and see how it can be used beneficially in the wheel. In the upper left are spoke washers, and then we have oval washers, what are called HM washers, and round washers. This is again the graphic with one hole, and if we look down on the hole from the outside of the rim, we see the rim bed here with a hole in it. Continuing from the outside view, we now have a nipple inserted through the hole. This is the cross-sectional view. In this case, we're just showing the nipple coming straight out. This is the same picture, except here now I'm going to use a washer under the nipple and then insert it through the hole, which then gives me this picture here. Let's focus first at the oval washers, the HM washers, and the round washers. This is the problem we're trying to avoid. Here we have just a plain rim with a hole in it, and we have sharp angles at the holes. And that's going to give me a small contact area between the nipple and the metal around the hole. And I'm going to have a large force, of course, from the spoke tension, and the two of those together are going to give me a large localized pressure, and that will result in time over developing cracks like this. The cracks always occur along the rim in the direction of the circumference. Here's one crack here. These are very common. If you work in a bike shop like I do, you see these coming in every single week. Lots of rims develop cracks. And here's another one here. Note again the direction of the crack along the length of the side of the rim. But if I insert a washer like this oval washer under the nipple, then I have this picture. Then I have still a large force from spoke tension, but now a large contact area, and that gives me a small localized pressure. Let's revise that statement and just say smaller, because we really don't know yet how pronounced that change might be. This is a ZIP 404 rim, carbon fiber. A close-up of the side view, you can see that this is a Firecrest model. In the Firecrest model, an oval washer like this is inserted through each of those holes and fits under the nipple. If I could see through the side of the rim, I would see this line here, which represents the inside of the spoke bed, so I can see there the thickness of the spoke bed. And then I would see this washer, and on top of that, the head of the nipple. If we look through this hole in the rim, we can perhaps see this shiny washer under the head of the nipple. Here's a close-up. For the Firecrest rim, the presence of the oval washer is critical to the strength of the rim. Unfortunately, the use of that washer is limited because it does not fit through the outside hole of the majority of rims. But these washers will. These are the Sypeme flat washers. You can see there from my caliper that these are very thin. You have to have a washer that's thin so it can mold itself and orient itself to the shape of the inside of the spoke bed. So a thick washer from a hardware store would not work as well. And here's another washer shown with this Sypeme polyaxial nipple is the Sypeme HM washer. Now that little washer is going to do some things for us. One is it's going to reduce the localized pressure that we just talked about. It also will provide a perfect surface against which the head of the nipple can turn, and it will also prevent the nipple from being scored from the sharp edges of the aluminum rim. I'm getting a perfect congruent fit between the bowl-shaped polyaxial head of the nipple and the shape of the washer. These three washers from Sypeme are the ones we just looked at. This is another one that I found recently. This is from DT Swiss, and this one has some nice applications too. The nipple fits perfectly into the washer. You can see in this close-up how the pre-formed shape of that nipple into kind of a boat shape fits perfectly on the inside of this extrusion under the head of the nipple. As I said a minute ago, I work in a bike shop and I see a lot of cracked rims, and it seems to me that in many cases that's an avoidable problem. If there is a downside to using washers, that is a reason for not using them. I'm not sure what it is because the mass of these washers is negligible and it takes an extra couple of minutes to lace up the wheel with the washers, but the benefits are immense. And you can take a lightweight rim that otherwise might be vulnerable to premature cracking and greatly extend its life by simply using a washer under the head of the nipple. Now, this is the washer we bypassed a minute ago. This is a spoke washer made out of a nice soft brass. That little washer is intended to go under the head of the spoke, which means it would go between the head of the spoke and the hub flange. Now, if I use my caliper here to measure the flange thickness, it's a little hard to read, but it measures 3.31 millimeters. In this picture here, I have a very nice fit of the spoke into the hub flange. I have no play or movement around the head of the spoke. But sometimes a washer doesn't fit, and the combination of the washer and the flange is too great, and the spoke cannot straighten out and will bend right there where the arrow is pointing. Let me show you a couple short videos, and you'll see this with better clarity.
What I mean is this: if I put the spoke in like this, I have no problem getting the spoke to rotate up like this to leave the hub flange at a 90-degree angle. This is without a washer under the head of the spoke. But if I try to insert this little brass washer under the head of the spoke, then I see that the combination of the washer and the flange is too thick, and I can't make the spoke bend up in order to go straight out like this without kinking right here at the neck of the spoke. I don't need a spoke washer in this case because I already have a perfect fit. But here I see an older hub with a steel flange which has a thickness of only 2.32 millimeters. And this thin flange means I will have a very poor fit of the spoke into the hub flange, and I have too much play, as you can see. Well, here's a perfect opportunity to use one of these really thin 0.5 millimeter washers made out of brass, which is soft, and it will mold itself to that empty space and fill in that gap that we just saw. These are very, very inexpensive, and they only weigh about 0.2 of a gram each, so that means you could equip two 32 spoke wheels
with these washers for a total of 12 grams in the wheel set. So my counsel to you here is use them if they fit. If they fit or don't fit will be quite obvious when you just test one. If it fits, not only do you get that structural benefit, but it looks kind of cool besides. Your most likely candidates are going to be hubs like this here. They're going to be older steel flange hubs that have a flange thickness of less than 3 millimeters.